RabbitMQ is a powerful open-source message broker that facilitates communication between different applications or systems. It ensures seamless data exchange by enabling asynchronous messaging, making it an essential tool for building scalable and resilient distributed systems. In this new video series on RabbitMQ, we will explore some of the core concepts, features, and some of the ways you can use this to build applications. I will be focusing specifically on building .NET applications. However, the core concepts applies to all other languages. RabbitMQ can be hosted through self-hosted deployments, cloud providers, containerization with Docker and Kubernetes, managed RabbitMQ offerings, etc. It offers a wide range of hosting options from complete control to fully hosted solutions. For the purposes of this video series, I will be using Amazon MQ, which is a managed message broker service provided by AWS that supports both ActiveMQ and RabbitMQ message brokers. In this video, let's learn how to get started by setting up a new RabbitMQ instance on Amazon MQ and start connecting to it from a .NET application to send and receive messages. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. RabbitMQ is the most widely deployed open-source message broker. You can get started by going to rabbitmq.com and start exploring the different features and core concepts of this message broker. The downloading and installing RabbitMQ section covers various options to install and host your own instance of RabbitMQ. Now, based on the operating system you're running, you can find the different options that you have to install RabbitMQ. You can also find information on how to host a self-hosted Docker instance, which might be another way to quickly get started to set up an instance and start playing around. There are also various cloud providers that provide managed broker services, which also makes it easier to get started with RabbitMQ. For this video, I will be using Amazon MQ for RabbitMQ. Amazon MQ is a fully managed service for open source message brokers. Now, this supports both ActiveMQ and also RabbitMQ message brokers. This makes it an easy choice to get started when you want to use one of these message brokers in the cloud and navigate away from your self-hosted instances, or even get started quickly when you're building new applications. So let's see how we can set up a new RabbitMQ broker instance on Amazon MQ. So let me navigate here to my Amazon console and let's navigate to Amazon MQ. Inside here, I already have a test broker set up, but I'll show you how to create a new broker. So let's head over to the Create Brokers. This prompts to select the broker engine type and gives the options between ActiveMQ and RabbitMQ. So let's select RabbitMQ and click Next. Now this offers different deployment modes, the single instance broker and the cluster deployment. The single instance broker is one broker in one availability zone. This is typically used for development or testing or for smaller workloads. However, when building a production application for a large-scale applications, you would be choosing the cluster deployment. In this, there are 3 single instance brokers connected in a mesh network across multiple availability zones. This ensures high availability and also message durability. For the purposes of this demo, let's select a single instance broker and click Next. Let's give this a name. So we can give this a name as my YouTube broker. You can choose a broker instance type which offers different instance options. For this purposes, I can choose a micro instance. Now, once the RabbitMQ broker is set up, you will need a username and password to connect to it. So let's specify that. In this case, let's give admin. And let's give a password in this case as well. Now, if you need to configure additional settings, you can use this to configure the new different settings. We will see some of these settings in later videos. For now, I will leave this as the default options. And let's click Next. Now we can review and create the RabbitMQ broker, and let's click the Create Broker. Now this is going to approximately take around 20 minutes, and you can see that it will be running once that is all set up and ready to go. Now, since I already have a test broker created, I will start using this for the rest of this video. So let's navigate into the My Test Broker and see how the details are once it's created successfully. Now here you can see the ARN for this broker instance, and we can also see the different statuses of this instance. Now if we navigate down, you can see the connections, which gives us the details on how to connect to this RabbitMQ. So if we navigate to the web console, It prompts us for the username and password. So let's enter the same username and password that we used when creating the instance, and let's click login. Now this takes you to the RabbitMQ web console where you can see the different options that is provided by this instance. We will start to explore some of these tabs in this video and also in the later videos. Let's see how we can start connecting to this from a .NET application and start to send and receive messages. Now, since RabbitMQ is message broker, when building applications on top of it, typically there are two different applications that are actually using the RabbitMQ. One, there is a sender that will send the messages, which is also called the producer, and then there is also the receiver, which is consuming the messages, which is also called the consumer. Now, these are the typical two parties that's involved when building message-based applications. Now, these two different roles can be hosted on the same machine or on the same process, or also on different processes and different machine. That depends on how your deployments are set up and how your application is structured. So to get familiar with some of the common terms used with RabbitMQ, producing means sending messages, or a program that sends messages is also called a producer. A queue is where inside RabbitMQ the messages can be stored. So even though the messages are being produced and consumed in the applications, the messages are actually getting stored inside a queue. A queue is only bound by the host's memory and disk limits. This means it is essentially a large message buffer. There can be many producers that send messages to the queue, and also there can be many consumers that receive messages from this same queue. Consuming has a similar meaning to receiving. It represents a consumer which receives and processes the messages that is being sent by the producer. So to start using the RabbitMQ from a .NET application, let's create two applications, one to send and one to receive the messages. So let me open the console window to create the new applications. So here inside the RabbitMQ Hello World program, I have a file which is setup.ps1. So let me open this file in VS Code, and here you can see that this is a script file that's creating a solution and two applications inside that. So here first I'm creating a new solution file with the name RabbitMQ Hello World, then creating the send console application, so which is of console type and named send. Now I'm adding the RabbitMQ.client NuGet package, which we will be using to connect and send messages to RabbitMQ. I'm also making sure to add the new project file to the solution file that we created in the first step. For easier purposes, I'm renaming the program.cs as send.cs. Now similarly, I'm creating a receive application, which is again a console application, which adds the RabbitMQ client so that it can connect and receive messages from RabbitMQ. Like before, I'm adding that to the solution file and renaming the program.cs to be receive.cs. Now this just automates the way to create the solution files, which I will be sharing in the descriptions below. So let's navigate back to my console and run this file inside here. This is going to create the solution file and the console applications within it. The script has successfully run. So if I list the directories again, you can see there is a send and a receive folder inside here, and also the solution file. So let's open this solution file in Rider and see the solutions that is set up for us. So here in Rider, I have the solution open and we have the receive and the send projects created. So if I open the send application, this has the send.cs, and similarly receive has a receive.cs. This is a simple starting point program.cs where we will be adding code to send and receive messages from RabbitMQ. Now to work with RabbitMQ, we have already installed the NuGet package, which is the RabbitMQ.client. So let's start connecting and sending messages to RabbitMQ instance that we created earlier in Amazon MQ. When connecting with RabbitMQ and sending messages to it, there are two concepts that's involved: connections and channels. All protocols supported by RabbitMQ are TCP based and assume a long-lived connection. Basically, you can visualize a connection as a TCP connection between the machine that is running your application, which might be the sender or receiver, and the RabbitMQ instance that is being hosted. Now, since it is undesirable to keep many TCP connections open at the same time, the connections are multiplexed with the concepts of channels. So these channels are lightweight connections that share a single TCP connection. So to send and receive messages, we will be creating independent channels and using that. So in a multi-threaded application, it is very common to open a new channel per thread or the process and not share channels between them. However, these channels will be sharing the same underlying TCP connection or the connection in RabbitMQ terms. Now, in the .NET clients that is provided by the NuGet packages, the channels are represented by using iModel interface. So you will be seeing some of the methods like create model, which represents the same as creating a channel. So let's see this by sending our first message to our RabbitMQ instance. So let's navigate back to Rider and let's open the send.cs and start sending a message. So let's first create a connection so that we can establish the connection between this application and the RabbitMQ instance. For that, we will first use a factory to create a connection. So we can use a new factory, which is a connection factory in this case, which is coming from the NuGet package RabbitMQ client. So let's create a new instance of this connection factory, specify the URI to this particular instance of RabbitMQ. Let's also specify the port, which is going to be 5671, which is the default port where the RabbitMQ instance is going to be hosted. And let's specify the username and password. You can store the username and password as configuration values and retrieve it from either the app settings.json or other secrets managers, etc. that we have covered in previous videos. For now, I will just hardcode it here in this application, which you should not be doing when building real-world applications. So let's put the password in here, which is rabbitadmin123 hash. Let's leave a note saying do not do this in real-world applications. Get this from a configuration file. So once we have the connection factory created, we can use this to create the connection. Before that, let's specify the URI for this connection factory. So if we navigate back to the AWS console, this is the URI that we need to connect. So you can see that the port is already specified in here, which is 5671, which we will remove once we paste it inside here. So let's remove that extra port information. Since this is a URI, let's create a new instance of a URI and pass in this string. Now, once we have the connection factory, let's use this to create a new connection. So let's create a new connection, which is going to be using where connection, the factory dot create connection. So now this is going to create a new TCP connection for us. Now, as we saw earlier, from the connections, we will be creating channels. So let's again using where channel and specify the connection dot create model method, which is equivalent to creating a channel in RabbitMQ speak. So now we have successfully established the connection with the RabbitMQ and created and opened a channel to communicate with it. Now to send a message to this RabbitMQ, we first need to create a queue. We saw that queues are where the messages are getting saved inside RabbitMQ. So let's create and define a queue first so that we can use this to send in the applications. So let's use the channel instance to create a new queue. This is done by calling the queue declare method on the channel, which takes in a few properties. So let's specify the queue name. In this case, let's specify hello as the name. And let's give all the other properties as false. So let's specify false for durable, exclusive, auto delete, and also let's pass the arguments as null. Now this is going to create a basic queue with the name hello. We will explore some of these different properties in later videos. Now once we have created the queue, we can start sending messages. So let's create a new message variable. We will be getting messages from the console so that we can type in the message and send this to this application. So let's start a do while loop to read from the console. Let's specify message is going to be console.readLine. Now, if you want to have a message prompt, we can also leave that. So let's say console.writeLine and say, please enter your message. Now, once the message is read, let's make sure that the message is not null or empty. So let's say if not string dot is null or empty, let's specify in the message. If this is the case, let's send this message to RabbitMQ. So let's create a new function, send message. Let's pass in the channel to it, and let's also pass the message itself. Let's create this send message function within this class. So let's create this. Now, if this message is null or empty, let's exit this do loop. So let's specify while not string dot is null or empty. This will keep on continuing this loop. Now inside the send message, we can use the channel and then send the message. So let's rename this as channel so that it's easier to understand, although it has the iModel interface. So let's use the channel basic publish method to send the message. It takes the exchange as the first property. Since we have not learned about exchanges, I will leave this as string.empty. We will later learn what this means in a different video. Now the next one is the routing key, which is going to be the exact same name as the queue name that we created. So let's specify this as hello, which will be used as the routing key for this example. We will learn about routing keys and exchanges in a future video to come. So let's specify the basic properties as null, and let's also specify the body of the message as the body. So now we have to specify this string as a byte array so that we can send this to RabbitMQ. So let's create a new property which is called body, and let's specify the body is equal to a byte from the string array. So let's use encoding UTF-8, and let's say the get bytes and pass in the string that is the message. So in this case, we can rename this S to be message. So once we have the bytes, we can send this inside the basic publish method. Let's also write this to the console. So let's say console.writeLine. Let's use string interpolation, and let's say send the message. So in this case, it's going to be send message. Let's format this and let's try running this application. So let's navigate back into our console. Let's go into the send application and let's .NET run. Now this has also sent the message to the RabbitMQ. This should be a T inside here, but we will fix that in the code later. So let's navigate to RabbitMQ. Let's go into the broker and let's go to this message console and let's navigate to queues. And here we can see that new queue that we just created with the name hello. You can also see that there is one ready message inside that, and there is a total of one message as well. So if I navigate into that, you can see the further details of this queue. Now if I send another message, so let's say hello again, and come back to our queue and refresh this, you can see that the message count has now increased to 2. So we have 2 messages in the queue ready to be picked up and processed. So let's wait no further and build our receiver so that it can process these messages. So let's navigate back to Rider. Let's come into our receiver class. Let's copy and paste some of these code that we already used in here. So let's create the connection factory, connection channel, and also let's declare the queue in the receiver as well. Now we do this because we don't know which application will be running, whether the sender or the receiver as the first application. Now the queue creation is an idempotent operation, which means it creates this queue only if one doesn't exist with the exact same name, which also means that if you need to change any of these queue properties, you will need to recreate the queue again inside your application. That is a problem for a different day. We will see that in future videos. Now once we have the channel, we can start receiving the messages and processing this. So let's write in a console.writeLine and let's say waiting for messages. Now to create a consumer and consume the messages, so let's create a new consumer instance that will be processing the message, and we can create a new instance of eventing basic consumer. This again is provided by RabbitMQ, and it provides us an experimental class that is exposing the iBasicConsumers method that is required to consume messages from the RabbitMQ. So let's create a new instance of this. Let's pass it the channel which it will use to consume the messages. Now, whenever the consumer is going to get a message, we will need to process it. So let's use the consumer.received event handler to register the function to process whenever a new message is received. So let's use this and let's add a new delegate into here. Now, if you navigate to the received, you can see that this is an event handler which takes in the basic deliver event args. Now, this event handler has a sender and also the event args as the parameter. So let's specify the model, event args inside here and write a function to execute what happens when a new message is received. Now, in this case, we'll need to convert the body back from the bytes. So let's specify body and let's specify ea.body.toArray. Now this is going to convert this into a byte array, and we can convert this back into the string. So let's use var message is equal to encoding UTF-8.getString and pass in the body bytes that we just got. So once we have the message, we can do the processing. In this example, I will just write this to the console. So let's specify receive and let's specify the message as well. Now we have created the consumer and also wired up the received handler in the consumer. Now let's specify to the channel to use this consumer using the basic consume method, like the basic publish method that we used earlier. Let's use the basic consume and let's specify the queue name, in this case hello. Let's specify the auto acknowledgement to be true in this case, and let's pass in the consumer as well. Now this is what is going to trigger the consumption from the channel using this consumer. So let's also provide a way to exit this application. So let's give console.writeLine and say press enter to exit, and write a console.read line so that it is waiting there for this enter key. Let's run this application as well. So let's navigate back to our console. Let's create a new tab and let's navigate to the same folder. So let's navigate to the hello world and the receive folder. So once we are there, let's use the .NET run again to run the receiver. Now once the receiver is running, it has two messages. So you can see there is hello world and hello again that is consumed from this queue. So if I navigate back into the queue and refresh this, you can see that there is no more messages in here. So now if I come back to our console and let's say testing messaging, you can see those messages getting received immediately from our receiver. Now this queue, if you see, you will not be able to see this messages coming up and queued here because our instances are consuming the messages as soon as they come. So we can keep on sending messages from one console to the other, which is flowing through RabbitMQ and getting consumed inside our receiver application. So once I stop this receiver, the messages is going to get piled up. So if I say message 1, message 2, these messages are going to come inside the queue and wait there until the receiver is back online to process that message. So if I come back and specify .NET run, you can see these messages are getting processed immediately and it's waiting again for new messages to arrive. I hope this helps you to get started with RabbitMQ and connect it from a .NET application. We learned some of the basic terminologies and the concepts that's involved when working with RabbitMQ. We saw how to host and connect with an instance on Amazon MQ. However, this will work exactly the same if your RabbitMQ instance is on a Docker instance, self-hosted, or on different providers. In future videos, we will explore more properties and advanced ways of communicating with RabbitMQ and using it to build applications. If you want to be notified when those videos comes out, please make sure to hit that subscribe button. And don't forget to hit that like button if you like this video and found it useful. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.